So welcome everyone to this short clip about Worcester College Mathematics and the joint degrees here. My name's Richard Earle. I teach maths here at Worcester. As you can see on the left there, there's quite a few of us that teach mathematics, and on the right you see a typical annual cohort at Worcester. This makes us one of the bigger colleges here. That doesn't matter too much, but it does mean that there's quite a society of mathematicians here. And you can also see that the numbers might vary a little bit from year to year. We have no fixed quotas. We're really looking to take the best people. So it might be that we have not one or two, say, maths and stats students, depending on the strength of the application field that year. It doesn't really matter too much because the students are treated as a cohort in that respect, and Maths and Phil students will be taught alongside maths students, and as well as obviously alongside philosophy students when they're getting their other discipline taught. So all those students are very much part of the same group, even though the teaching arrangements might be a little bit different. What's an average week like being taught here? Well, the process for how you meet mathematics is essentially you go to some lectures, you meet the mathematics, you probably won't take it all in initially. You then spend a good while going through some problems that are meant there to challenge you, to have you thinking hard about how the material just met coheres, putting it all together, and then a while afterwards you have a tutorial on this. So in the image there you see a tutorial taking place. It's actually in the same room as I'm making this clip from. And I'm there teaching, and you've got 3 students. And that's relatively typical. It might be 1, 2 or 3 students. What's a little different at Worcester, at least in the first few terms, is that rather than having 2 to 3 hour long tutorials, which might be the long-term arrangement for teaching, in the first year you tend to have shorter tutorials, perhaps in groups of 3 rather than paired hour-long tutorials, but it means you'll be meeting tutors perhaps 4 or 5 times a week. And the nice thing about that is that's a nice transition from the way that maths is taught in schools and colleges, where you'll have quite a scheduled timetable and you'll be meeting, well, basically you'll be in school or college all day long, to the arrangements we have now at university, where you're much more in charge of your actual teaching timetable and your study. So you're in a situation where you have to organise yourself a lot more. So this is a nice gentle transition to a more to the long-term arrangement where you have 2 to 3 tutorials a week. It does mean, given that we ask our students to do about 35-40 hours work a week, there's a lot of independent time that you're putting in the effort. Talking to other students, of course, is allowed, and we like to see students helping one another solve the problems. And then at the end of the week, you'll have these tutorials where you can iron out any bits and pieces you haven't been able to quite finish yourself. Might be worth saying at this point that by the 3rd or 4th year, intercollegiate classes become the norm. So as the options become really very widespread and diverse, no single college can teach like that. So different students interested in a subject will come together to be taught by an expert in that subject who may well be at another college, and that's how things will be arranged in the 3rd and 4th year. What about the application process then? So if you want to apply for maths or any of the joint degrees, this is an important timeline for you. So 15th of October is when the application needs to go in via UCAS, and it's also the case by 15th of October you need to register for the MAT, and this is something you do through your school or college. And the MAT is a test we use to shortlist the 9 or so applicants we have per place down to about 3 applicants per place we have for interview. As you can see there, the MAT is on the 4th of November. It would normally be the case after the MAT had been taken and shortlists had been made that people would be invited to Oxford for interview. Now, in the current pandemic, it seems highly unlikely that interviews will be taking place in December in Oxford. So it's going to be the case, much more likely, that interviews will be done remotely via something like Skype, but in December still. But you should listen out for more details and confirmation of that. And then once that application process is essentially over, conditional offers will be made in early January. It might be that some offers are unconditional, with confirmation then being the following August, at least in a typical year. So all of this is there's potential for it to change this year given the current circumstances. So do look out carefully for the arrangements that are going to be put in place this year. But the first step here is really that to be putting an application in and registering for the MAT, which is sat usually in your school and college, by October the 15th. What's university mathematics like? I mean, one of the main things to get right is to know that you're applying for a subject you enjoy. If you enjoy mathematics now, I think there's a very good chance that you'll enjoy mathematics at university. It will be more challenging, but it will definitely also be a lot more varied. So here are just some images pointing out some of the different bits of mathematics that you might do in a degree. So in the top left we have the 8 symmetries of a square, the 8 ways you can take a square back to itself, 4 rotations, 4 reflections, and together they make something called a dihedral group, D8 in this case here. So this is all part of something called group theory, and that's an important bit of pure mathematics, though its applications are wide within mathematics. To the right of that, and quite topical now, is an epidemiology model. So you've got 3 groups of people, the susceptible, the infected, and the resistant or recovered, that are variously catching a disease as it passes through the population. This was an early epidemiology model. Below that is a diagram showing off some of Kepler's laws. The fact that in a two-body system that you would have under gravity here, you would have particles moving in elliptical orbits, and you can also see one of his other laws there, that in a certain amount of time, the sector area there will be always the same, as long as you fix the amount of time between the points of the planets are out there. The sectorial area will be the same. Excuse me. And then in the bottom left there's a theorem, Pascal's theorem in geometry. If you've got yourself a conic and 2 triples of points here, A1 to A3 and B1 to B3, and you join the points up as you've seen there by lines, then the intersections you see will always be collinear. So this is a theorem of geometry. And these are the things you might meet in your degree. In the mathematics degree, it's important the first year is core, so you don't have any options early on. And there are good reasons for this, because just because you've met a subject before doesn't mean you've met it with the appropriate emphases at university. But it's also the case that you might come here thinking, oh, I don't want to do statistics, I've not enjoyed statistics at A level, and then you come to university and actually realise the variety on offer in probability and statistics is a lot more varied, and things are really done quite differently here. So it's important that you get a chance to see all these things and how they're taught at university before making any choices going into the second year, where options pretty much kick off from the first term onwards. So some things you can be doing now, in particular in this calendar year, if you're going to apply, then a lot of this is going to be about the application process. So being on top of the MAT syllabus, which isn't big, but you wouldn't want to be forgetting any important elements from that, especially during the MAT paper. Doing some MAT practice, getting used to the style of the paper, getting used to being a bit stuck and not letting this phase you, and other questions that might stretch you that you can find, perhaps some step 1 questions at this point. Reading around can be a good idea from a point of view of confirming to yourself that a maths degree is something you want to do. But really the most important thing is to be doing maths. Reading a popular maths book might entertain you, might reassure you that you want to be studying such things at university, but you won't really be improving your mathematics. So were you to be made an offer, or indeed just generally if you're thinking about going to university, then next year, as in 2021, it's a good idea to be improving your mathematical skills and such. The main thing is making sure you get the grades though. So you wouldn't want to be doing all this extra work and miss any offer. But if you get to a point where you're feeling secure about your grades, maybe even finding A-level and further maths a bit boring by now, and you want to be looking for further things to do, then it might be you want to improve your ideas about proof, which is definitely an important aspect of university maths. But if that isn't quite your thing so much, there's all sorts of other maths you can be doing, and questions actually designed to help you make connections through different bits of mathematics. So there's various books that have been written, I've written one myself, that give you sort of slightly more challenging problems that are sort of like helping you appreciate how mathematics works together. But doing something to stretch yourself in 2021 is a good idea. Stretch yourself mathematically, but you would never want to be doing this at the cost of your actual A-level and further maths work and putting your grades in any jeopardy. How can you find out more? Well, there's all sorts on the web, full stop, but there's bits and pieces here relating to mathematics at Oxford. So you've got on the left there a copy of the departmental prospectus that you can download. There's various things that are online relating to the department that you can find out. We had 2 open days in April earlier this year, 2 virtual open days, and all the material there, including a talk from me, you can find, including a talk from Vicky Neal, who's in the bottom right image there. So you can find plenty about the department there. Anyway, I hope this has been useful. By all means, write in to the college or to the department if you've got further questions about mathematics. But with that, I'll finish now. Thank you.
Hi, I'm Felix Parra. I'm one of the Worcester physics tutors. I'm a theoretical physicist interested in extremely hot gases. In particular, I focus on fusion plasmas, which are gases that are heated up to 10 times the temperature of the sun, and we use them to try to get electrical power from seawater and lithium.
Hi, my name is Rob Smith, and I'm one of the physics tutors at Worcester. As well as teaching, I also run a lab that investigates and matter some of the coldest temperatures in the universe. We cool gases down to less than a millionth of a degree above absolute zero. These temperatures, the atoms no longer behave according to classical physics. Instead, we enter the weird and wonderful world of quantum mechanics. We use these ultra-cold gases to explore and better understand this world, which, as well as being really fun, might help in the development of new technologies such as quantum computers or better gravitational wave detectors.
In my opinion, the Oxford physics degree is very complete, and it covers a wide range of topics. In our first year, we revise some of the A-levels material, and we build the base in maths and basic physics to continue a degree in the next years. In second year, we teach what are the 3 pillars of modern physics: statistical physics, electromagnetism and optics, and quantum mechanics. In 3 years, students start specializing, and they can have some choice in the subjects that they study. And in 4th year, they actually separate into different paths, and they can actually get 2 types of degrees. they can do a more experimental physics-oriented degree, the Master of Physics, or a more theoretical physics-oriented degree, which is the Master of Mathematical Physics.
At Oxford, the teaching of the physics degree is very much split between time in the department and time in college. The teachings are made up of lectures, practicals, and tutorials. The lectures, which teach the core material, usually happen in the mornings in the department and take around 10 hours a week. Practicals also take place in the department and take around 1 day each week. In these, you both learn the techniques to be an experimental physicist and also see for yourself some of the effects that you learn about in the lectures. Then there are tutorials, and this is what takes place in college. In these, you meet in groups of 2 or 3 with your tutor to go through physics and maths problems that you'll have been set in advance. And it's also your chance to ask about anything that you want clarifying from the lectures. These tutorials, which as I say happen in college, you'll have about 2 to 3 hours of them every week. For example, in the first year, you will meet with both Felix and I once a week for around 1.5 hours.
The experience here of undergraduates at the University of Oxford is quite unique, and I think I can say that with a degree of confidence, because I have been very fortunate to experience university education in 3 very different settings. I studied my undergraduate in Madrid, so I did experience a typical continental European university. Then I was a professor at MIT, so I did get to teach at a top American university, and now I teach here in Oxford and in Worcester. And the tutorial system is simply amazing and unique. The students get the opportunity to be close during their degree to top researchers. And as a teacher, it is incredible to have the opportunity to get to know your students so well and to be able to help them in such a personalized way.
We're basically looking for students who have both a strong motivation to study physics and also a natural ability to do so. So we look for candidates who show a keen interest in physics and a strong desire to learn. We also look for those with good physical intuition and an ability to express, analyze and solve problems using mathematical language.
We use the information in the UCAS form, the predicted grades and the PAT exam result to evaluate the students' motivation, mathematical ability, reasoning ability, and physical intuition. Unfortunately, we cannot interview every person that applies for an Oxford Physics degree, so we have to use the UCAS form and the PAT exam result to pre-select a few that we interview. During 3 interviews, we again test the mathematical ability, reasoning ability, and physical intuition of the student, and we get an impression on how they communicate. With all this information then, in collaboration with the rest of the physics department, we take a decision and we admit a few people. The idea behind doing it with the rest of the physics department is to make sure that an applicant's chances to get admitted do not depend on the college of their choice.
In many ways, we're trying to run the application process in a way that doesn't advantage those who had the benefit of lots of help to prepare. Having said that, there are, of course, things you can do to prepare and help yourself. Probably the 2 most important parts of the application process are the physics assessment test, or PAT for short, that everyone does at the beginning of November, and the interviews that all shortlisted candidates have at the beginning of December. The best way to prepare for the PAT is to do some practice papers. There are many past papers available on the physics website, so I'd encourage you to download some of these and do plenty of practice in solving the problems. In the interviews, you'll also be asked physics and maths questions. And in this case, we're less looking or less interested in whether you can solve the problem. I'm more interested in how you go about trying to solve them. So good advice would be to come prepared to be asked questions that you don't know the answer to. And so don't be worried when this happens. and be ready to explain your thinking in trying to solve these tricky problems. Good luck.
Hello and welcome to our open day here in Worcester. My name is Neil Vulcan and I'm the Management Fellow. I'm a professor at the business school, and my own research, I focus on fintech, algorithmic trading, and on market design. I don't know if any of these things mean anything to you, but that's what I do for my research. And I'm responsible, together with my economic colleagues in Worcester, for the economics and management course here in Oxford. If you do come here, I'm most likely to teach you the first year course in management. It's called General Management. It's one of the 3 main courses that you do in the first year. Typically, you will have 3 courses a term, which means 3 sets of lectures and 3 tutorials every week, for which you have to prepare essays. So it's quite a busy course, and you'll have to really learn how to manage your time. If you are thinking of applying for economics and management in Oxford and in Worcester, you should know that you have to do the TSA test, and details of that are on the university webpage. I'm afraid this is one of the most competitive. I think in the last few years it is the most competitive course in Oxford in terms of the ratio of applicants to places. So you'll have to do well on this test, I'm afraid. You have to do well on the TSA test in order for us to consider you. You'll have to have a maths A-level. It's not required that you have economics A-level, although most of the people that we see have it. It's not compulsory. Although, of course, when we interview you and we'd like to know, why you chose to do it or not to do it, because the other thing we would like to see is obviously your interest in the subject, your interest in economics and your interest in management, in order to be accepted to this. It's a very good course. I know I'm biased because I teach it, but I think it's a very good course, and it opens a lot of doors. And the business school in Oxford, where I work, is one of the top business schools in the UK. Our students tend to do really well after they graduate in terms of the kind of jobs they get, whether it's they stay in academia or they go to government or they work in investment banking or in management consulting or in many other sectors. So I hope this was useful. I hope that you will choose to apply to this course. Goodbye.
Welcome to Engineering Science at Worcester College. My name is Ton van den Bremmer. I'm the tutor and fellow in Engineering Science. In fact, one of the 2 tutors and fellows in Engineering Science at Worcester. So I will take you through a number of questions that will introduce you to Engineering Science teaching at Worcester College. Question number 1 is, what does the study of engineering science actually involve? So when we study engineering, we're interested in using physics and mathematics to create models of the world around us that will allow us then to improve the world around us. So applications can be in building bridges, could be in developing healthcare technologies, or it could be developing computer algorithms that will allow self-driving cars to drive. So it's very broad. In which subject do I specialize? Well, when you come to Worcester, you will be taught by a number of different tutors who each have their areas of expertise. And I do research and do teaching in fluid mechanics. And in particular, my research is in the area of the fluid mechanics of ocean waves. And a lot of my teaching is in understanding fluid flows, understanding the mathematics required to model fluid flows, and the physics of fluid flows. Question number 3, how is my subject, engineering science, how is it usually taught at Worcester? In addition to the tutorials, in addition to the lectures and labs that you would have in the department, you would have tutorials. These tutorials are usually in groups of 2 to 3 students, and you would come to a tutor's office, my office, for example, virtually or in reality, and you would engage with tutorial sheets with questions on them that relate to the lectures you've been in, and these questions you will have had time to prepare, and then you'll come into my office and you will actually be working through those problems, arguing why the solutions should or should not be the solutions you've identified, try to write on the board and explain the topic at hand. Question number 4, how many hours would you have at Worcester? Well, most of your teaching will be in the department, that is your lectures and your laboratories. And in addition, you would have 2 hours of tutorials every week with a subject tutor in the small groups that I've explained. In addition, we would have engineering meetings at the beginning and end of term where you would be able to interact with the students in other year groups, and we would have meetings with you at the beginning and end of term to make sure that you're progressing well. Question number 5, what do we look for in a competitive application for your subject? Well, what we're looking for is the ability to develop a talent for using physics and mathematics to create models for the world around you. Question number 6, how important is each step in the application process? There are a number of different steps. You would write your application onto a UCAS form, which would include a letter from yourself and from your school teacher often, and there would be marks achieved as well as marks projected. You would sit an aptitude test, and you would actually, if we think this is justified, we would invite you for interview. And when we make the final decision, we would look at all those factors combined. So there is no single most important step. Question number 7, are there particular resources I could suggest, books or web pages? And the answer to that is no. I would encourage you to take an interest in how the world around you is engineered, how it is designed, how it works and why it works the way it does, and use various resources you can find online to understand really how things, and things can be very many different things such as airplanes, cars, technologies on your phone, healthcare technologies, anything that requires some sort of clever engineering design. I would encourage you to work out how these things work. Finally then, what's the most exciting thing about studying engineering at Oxford? Well, I believe the most exciting thing is that we take an interest in your personal development from the day you walk through our doors. We take an interest in your learning and make you develop into a good engineer, one who can use mathematical and physical models to make the world a better place. We look forward to your application at Worcester, and thank you very much.